Yes, I think we might flip it. We might flip it later.
See how it works.
That could be exciting.
Good. Okay. So here we go. We just took a moment and refreshed our memories. I'm going to, now you're in Algebra 2 trigonometry. We're going to go all the way to trig. Geometry just gives you a small taste. This symbol is a Greek letter called theta. And it looks like the letter O, cursive-ish. Sometimes I let mine go all the way to the middle. That's ish, okay? So it's a Greek letter. The Greeks are really the ones that developed a lot of trigonometry. So from theta, this is the opposite side, this is the adjacent, and this is the hypotenuse. So your SOHCAHTOA does stand for the sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, but it's from an angle. Now, you only learned about 3 trig functions, sine, cosine, and tangent. Well, there are 6. So what we're going to do is we're going to start off with sine, theta, is opposite over hypotenuse. But I want you guys to do a nice habit for me, is below it, we're going to put its reciprocal trig function. So this is new for you, and I'm going to spell it. CSC stands for cosecant. This is cosecant. And we do abbreviate it CSC. But I always want you to do your trig function with its reciprocal underneath, okay? We're going to go that route. Then we have cosine theta. Cosine theta is from SOHCAHTOA, adjacent over hypotenuse. Its reciprocal is secant, and we abbreviate it SEC, and I'm going to spell that. That's secant. And the last one is tangent theta, which is TOA. I think of bionicles. My boys were really into bionicles. Remember the TOA?
I am not proud to say that I read every single
That makes me giggle.
like 10 years ago.
Okay. And you spell cotangent like this. But please don't ever call sine sin theta. I mean, it is sine. It is spelled S-I-N-E, but we abbreviate it S-I-N. You don't say, well, sometimes we do say tan theta, but it's tangent theta. But don't say cos theta, it's cosine. And secant, it's not sec.
One more letter. Why did you abbreviate it to 3?
I know. Well, because all the other ones were 3.
Okay.
Yeah, that's the only reason. Okay, so let's look at example 1. In this triangle, I need you to fill in some stuff. So for the most part, you're going to find this section to be very straightforward.
Yay.
We like that. So this is the given information. And I am going to make a request, just because if I have 30 students doing this all different ways, 6 different ways, it's really difficult for me to check. So I'm going to ask you to sort of go in this pattern of sine, cosecant, cosine, secant, tangent, cotangent. Otherwise, I'm trying to hunt for your answers. So it says in example 1, this was the given information. It says evaluate the 6 trigonometric functions of the angle theta. So I'm going to start with sine theta. And I know from SOHCAHTOA that's opposite over hypotenuse, but there's a problem. They didn't give me the hypotenuse. So I have my math tool belt, and I know Pythagorean Theorem, and I can find the missing side. This is 5 squared plus 12 squared. It does not matter what letter you use. You can use X, you can use A, B, C, whatever you want. So I'm going to use C because it's the hypotenuse. That's 25 plus 144 equals C squared. That's 169. So C is 13. This is a very common Pythagorean triple. You know 3, 4, 5? Well, 5, 12, 13 is another very, very common Pythagorean triple. So now I can do sine theta. It's 12 over 13. So right below it, we're just going to do cosecant and flip.
Oh, is that why I was asking about the reciprocal thing? homework?
Yes.
Okay.
Does that make sense now?
Yes.
Cosine theta would be 5 over 13. Its reciprocal is secant theta. So we just flip it. And last pair, tangent theta is 12 over 5. Its reciprocal is cotangent theta. Alright, I want to pause here a moment before we move on because I want to show you a common mistake and I want us to see if we can figure out why there's a mistake. It's not anything I want you to write down, more that we want to think about it and talk about it. So let's look here, okay? I left this up from the other class. I have this triangle and the problem says find 6 trig functions of A, and this is what the student wrote down. But it's wrong. Why is it wrong, Carmel?
Because it's not telling you which angle. I mean, it is, but in the answers, you're not saying what it is.
Okay, exactly. Do you see? First of all, it's not telling us the angle. What, Elena?
Sine is. Oh wait, never mind. Ignore me. I'm good.
Okay, because you know they really have the right fractions. Okay, sine of A is 12 over 13, but they didn't put the angle, but why is that important? Why do you need the angle? Like, okay, they got the right answer. Is that all we care about, Henry?
Because if you look at it from if you look at it from C, it's going to be different than if you're looking at it from A or B.
Right, and then, you know, when you're looking here, okay, yes, the problem did ask you for A, but I have students each year that will write this down, and then I take points off. There are 3 angles here. Which, okay, yes, it was asking you about A, but you have to say, and SOHCAHTOA only makes sense coming from an angle. So I need you to make that connection in your brain that, okay, yes, it's the opposite side over the hypotenuse, or opposite over adjacent, or whatever ratio, but it's more important that you're understanding where are you coming from, where are you looking, okay? All right. So just wanted to take a moment to do that. All right, now in example 2, it says if theta is an acute angle of a right triangle and sine theta equals 4 over 7, what is tangent theta? So I want to break this down, or actually have you help me break this down. So McKenna, when it says theta is an acute angle, from geometry, let's just look at that little phrase. What is an acute angle?
It's less than 90 degrees.
It's less than 90 degrees, okay? And it's in a right triangle. So I'm going to stop a moment and I'm going to draw a right triangle. And if it's in a right triangle, those other 2 together add up to 90, so that means theta and the other one are definitely acute. All right, so then Andrew, when I look at sine theta equals 4 over 7. What can you just tell me about sine theta equals 4 over 7? What's that telling us?
That the opposite is 4 and the hypotenuse is 7.
Awesome. Okay, do you guys see how, like, you really want to pick apart your problems? So, yeah, SOHCAHTOA, sine is opposite over hypotenuse. All right. Henry, what do you know about tangent theta?
It's the opposite over adjacent.
Okay, it's opposite over adjacent, but we're missing the adjacent, right?
So we do a Pythagorean theorem.
All right, let's do a Pythagorean theorem on it. So I'm going to say 4 squared plus b squared equals 7 squared. That's 16 plus b squared equals 49. So b squared is 33. So that missing side is the square root of 33. Let me refresh your memory. We simplify all radicals. We rationalize all denominators, okay? That's an assumed thing we do. So now, Henry said tangent is opposite over adjacent. So then, Elena, what do I have to do to this answer?
Multiply it by -33. Radical 33 over radical 30.
Okay.
I
So
can't
that's
talk.
4 radical 33 over 33. Okay? All right, special geometry, do you remember 30-60 right triangles and 45-45 right triangles?
Yes.
You are expected to remember those. I'm going to briefly go over it. If this is too rusty for you, come into math study table and I can reteach and do much more with you. But it is assumed you know this. So in a 30-60 right triangle, if you go across from 30 is 1, the hypotenuse is double that, and then across from 60 is 1 times radical 3. And this is going to be our foundational 30-60 right triangle. In a 45-45 right triangle, that's really an isosceles right triangle, so the legs are 1, and then the hypotenuse is times radical 2. Okay? So what we're going to do, you're supposed to know that. If you don't, make index cards and study it and get those down. I'm going to start filling the chart in, and then I'm going to give you a moment to fill in the rest of it. So if I want to know the sine of 30 degrees, I go to the 30-60 right triangle, and I think of SOHCAHTOA. It's 1 over 2. At the same time, I'm just going to go over to cosecant, flip that, 2 over 1 is 2. Okay? If I want the sine of 45 degrees, I go to the 45-degree triangle, and I do 1 over radical 2. I'm going to pause right there, flip it, and put it in my cosecant column. But I can't leave a radical in the denominator. Are you guys comfortable at this point of the year, this is towards the end of our school year now, that you know how to rationalize in your head that that's radical 2 over 2? And then the sine of 60, so I come over here to 60 degrees, that's radical 3 over 2. Alright, I'm going to flip it, but bummer, I have to rationalize, that's 2 radical 3 over 3. So what I want you to do now is I want you to do the cosine column and secant as you do that, and then do tangent with cotangent. Then I'll fill it in. Check it with the board when you're done. And you are going to be expected to be able to find each of these values. I don't expect you to memorize them, but what tends to happen is you accidentally start memorizing them. Sine 30 degrees is 1/2. Also notice cosine 60 is 1/2. Do you see those? And cosine 30 is the same as sine 60. That's not an accident. We'll eventually discover why that is. And notice sine and cosine 45 are the same. And that tangent 45, cotangent 45 are the same, like that. Okay? Alright, so let's look at example 3 together. I need to give you some things here. Alright, if you are given the following items on this right triangle, it says find the value of x. So what I want want us to do is I want us to look at this in terms of, okay, I've got 30 degrees, and I have x and I have 8. X is the adjacent side, and 8 is the hypotenuse. Hannah, what trig function does adjacent over hypotenuse from SOHCAHTOA? Adjacent, hypotenuse. Look at the front of your paper where you wrote SOHCAHTOA. One of them has adjacent and hypotenuse.
Cosine.
Yes, it's going to be cosine. So this is cosine 30 degrees equals x over 8. Now, what you're expected to be able to do without a calculator is if I'm ever asked any of those 6 trig functions of 30 degrees, 45, or 60, that I can come up with them without a calculator. So what you want to do is you want to draw 1, 2, radical 3. And I want to pause here a moment because I know students know those are the 3 numbers, but they sometimes label them incorrectly. And I want to clear that up so we don't ever do that. If you reason it out, you can't get this wrong. Do you remember from geometry? The smallest side is across from the smallest angle. So 30 degrees is smallest, 1 is the smallest. 90 is the biggest, and 2 is the biggest. Now how do you know that? Well, radical 3 is in between radical 1 and radical 4, right? Radical 3 is in between radical 1 and radical 4. So it's bigger than 1, but it's less than 2. So do you see how you can always put the numbers in the right spot? So now cosine 30, SOHCAHTOA, is adjacent over the hypotenuse. And then this is a proportion. Just cross multiply. Divide by 2, and x is 4 radical 3. Now let's go back because I went kind of a longer route on this because I want to develop a good foundation here. Let's go back. There was actually a different way, a much faster way to do this. Do you understand that if you're given in a right triangle 30 degrees, the missing one was 60? Across from the shortest side, do you remember it's always half the hypotenuse? And then this one, the long leg, is the short leg times radical 3. Okay, and I did know that. But I wanted to work you through this because sometimes it'll get more complicated and we need to understand that process. Okay? All right, next topic. Solving a triangle means find all missing sides and angles. Find all missing sides and angles. It says, note, solving right triangles that have acute angles other than 30 degrees, 45 degrees, and 60 degrees may require the use of a calculator. But if it is 30, 45, 60, you have to be able to do it by hand, and I'll force the issue on a quiz, so I'll put it on the no calculator part. So do not use your calculator all the time, okay, because that'll get you into trouble. All right, so example 4 says solve triangle ABC. And let me give you the given information. And something else I need to mention that's assumed you talked about last year in geometry. When you have a triangle, angles are described with capital letters. Sides opposite those angles are lowercase letters. That should be a common thing in mathematics. So I need to find angle B and side A and side C. Well, the easiest thing to do is to find the measure of angle B. So if I have a right angle, that means the other 2 angles add up to 90. So I just need to do 90 minus 28. So that's 62 degrees. All right, so if I want to find side A, Megan, I have the opposite of 28 degrees, and I have the adjacent. So I have opposite and adjacent. Which trig function is opposite over adjacent? Tangent. So we're going to write down the tangent. 28 degrees equals A over 15. Alright, so what I just told you in that note was that if it's 30, 45, 60, we do them by hand. But if it's anything other, we need our calculators. So, I know you've heard me say repeatedly to my pre-calc students, check your mode, check your mode. The next 10 weeks I'm going to tell you, check your mode, check your mode, check your mode. What we're going to do is we're going to multiply both sides by 15, and I need to enter 15 times the tangent 28 degrees. So, let's take your graphing calculator, and you need to press the mode button. Yours is, if it's set on a standard setup, it's on radians, and we need to move it to degrees. So go down here and press enter on degree. And then we're going to do 15, press that tangent button, 28, and I'm getting 7.956, boy that's really close to 8, isn't it? So A is 8. Now something else I want to mention to you is A is now a rounded answer. So when you continue to do work, you want to do your best to use the given information. I would rather use the 15 because if I use a rounded answer and then I round again, I get further and further away from accurate answers. So we're going to stay away from using A because I can. So then Jaslyn, if I want to find C and I have from 28 degrees, I have the adjacent and the hypotenuse. What trig function is that?
Cosine.
Okay, cosine. That's cosine 28 degrees equals 15 over C. Now you guys, I could use 62 and I could come this way and use a different trig function. It doesn't matter which of those two angles you choose. Now, students tend to get this one wrong because C is in the denominator. You do not want to divide by 15. Dividing by 15, C is still in the denominator. Do you understand that? C is still down there. So what you want to do is you want to create a proportion, or you could just multiply both sides by C, and that would get C out of the denominator, okay? Either way. So this is C times the cosine of 28 degrees. I'm just going with the proportion. And then I'm going to divide by the cosine of 28 degrees. So be careful if your unknown is in the denominator. It's got to come out. So either create a proportion or multiply by that variable. So now on your calculator, take 15 divided by cosine 28 degrees. It's already in degree mode, so we should be okay. And are you getting about 17? Okay, good.
Do you want us to round them and not just leave it in the decimals?
It'll depend, like it might say in the textbook, or you might look in the back before you get going. If they rounded 1 decimal or 2 decimals, just round the way they did. Otherwise, it doesn't matter. It doesn't matter. All right, let's look at example 5, and I'm going to have you put some labels on here. The diagram was already given. It says, while standing at Yavapai Point near the Grand Canyon, you measure an angle of 90 degrees between Powell Point and Woodfirst Point as shown. You then walk to Powell Point and measure an angle of 76 degrees between the Y and the W. The distance between Yavapai Point and Powell Point is about 2 miles. It says, how wide is the Grand Canyon between these two places? So that's, we're going to call it X. So from here, Carmel, from 76 degrees, I have opposite and adjacent. What trig function? Tangent. So we're going to write tangent 76 degrees equals X over 2. So in this case, I can multiply both sides by 2. In a word problem, make sure you're including units. I did round to the nearest whole number, and I got 8 miles. So just check it that you know how to use your calculator. All right, any questions on the computation? All right, we have something called angles of sight. And I'll tell you, my pre-calculus students struggle with this sometimes. So let me go over this and make sure we're clear. An angle of elevation is from a horizontal line looking up. And an angle of depression is, again, from a horizontal line looking down. And I want to point out, and it's just because my pre-calc students struggle with this, is if you go back to our Grand Canyon picture, I have students who want to say this is the angle of depression. I'm like, that's not from a horizontal line. You have to create the horizontal line, and this is your angle of depression. But if you remember, in a rectangle, these are parallel, cut by a transversal. This one and this one are alternate interior angles. You've got to remember that. But this one is never, from a vertical, is never the angle of depression. Okay, but that's what they want to do. And they don't draw the horizontal line. All right, so let's look at example 6. It says a parasailer is attached to a boat with a rope 300 feet long. Okay, so let's draw our boat. And we have a parasailer. There's our little person. And it says the angle of elevation from the boat to the parasailer is 48 degrees. An angle of elevation is from a horizontal line looking up. So we're going to draw from the boat. Here's my angle of elevation. It's 48 degrees. And what we're going to do, and we do this in mathematics a lot, is we're going to drop a perpendicular, because if it's a right triangle, I've got good tools in my belt. I've got SOHCAHTOA in there now. So if I want to know the parasailer's height above the boat, I'm not looking for the length of the rope. This is the height. Do you see that? And really, there's a perpendicular parallel here to that height. So this is from 48 degrees opposite over hypotenuse. What trig function is that? Sine. So we're going to do the sine of 48 degrees equals h over 300. And so then you will multiply both sides of this equation by 300. So I rounded to the nearest whole number. Again, with word problems, make sure you're including the units.